card. All right. And so like we do when we build these apps, we'll start from scratch. So we're going to delete all the code and put it into the backpack. It's going to take me a minute. Wait. Delete. To backpack. So I'm just going to put everything into the backpack and then delete it. This will take me just a minute or so. Oh, there's a slightly faster way. We just add everything to backpack, to backpack, add to backpack, add to backpack. And almost there. There we go. And let's go to designer and just delete things from there. Right, so delete everything from here and it will delete the code as well. So we'll just start with a completely blank slate. Everything is gone. Wonderful. Oh, so exciting. Yeah, almost everything is gone. Let's delete whatever is left. Nothing. Into the garbage can. There we go. And that's it. Yeah. And when you want to follow this on your own, you can also refer to the checklist, which will lay out the steps one by one. Okay. So now the first question we perhaps want to ask ourselves, let's start with the designer. Yeah. So what do we have? So on the top of this, we have a label that just says US precedents. Let's go to the user interface drawer, grab that label. And underneath that label, we show an image, right? So let's go to the image component, still in the user interface drawer. So image component is what we use for showing pictures, text, or the label component is what we use for showing text. You know that by now. And we'll grab, what else do we have? We have the question, and the question is text plus the image. We already got the image. So let's grab another label component to show the question. And then under this, we have a text box for the player to enter their answer and a couple of buttons. So let's grab a horizontal arrangement, put it right under the text label and back to the user interface. And the text box is what we use for the player to give their answer, to give any kind of a text input. So we collect it with the text box. So let's put it there. It appears right under the horizontal arrangement. And what do we need? We need two buttons. So let's grab two. And now let's rename some of these so we can keep track. So the label, let's see, the first label, that just says US presidents. So let's just put that text in there. All right. And it should show US presidents. And let's make it a little bigger, increasing the font size to 18. There we go. That's more readable. Image. Yeah, image. Let's see about that. Let's maybe, so this being a starter app, I have already uploaded the images like Nixon. So let's pick one, maybe Roosevelt and Churchill, and let's just set the image component, which has a picture attribute, to Roosevelt and Churchill. And it's overflowing the screen. So let's just make the width to fill parent and let's leave the height automatic. So it will take care of itself. Yeah.
Okay.
All right. Now this second label below the picture, that is where we show the question. So I'm just going to rename it to question label, just so it's easier to keep track of things. Did I spell that right? Question label. Yeah, I think I spelled that right. And then What else is there? There's a text box where we get the response. I think I'm going to leave it as it is. The button, there are two buttons. So let me just give them names so we know what they are. One is the submit button that just will allow the user to submit their answer. And the second is the next advanced button. So let's call it the next button. Yeah, now we know how to tell them apart. And the submit button just says submit. Let's put that in there. And the next button just says next. So let's put that in there too. Always make these look like pictures, etc. And let's make a few more enhancements. Let's go to the screen and make sure everything is, all the components on the screen are center aligned. They already are. That's good. What else do we need to do? Let's go to the horizontal arrangement and let's give it the freedom to take up all the available space from left to right. And again, let's center align all the elements inside the horizontal arrangement using the align horizontal property. I think that's done. I think we are good to go and start coding. Yes, this text for label 2. Yeah, so that shows the question. Yeah, we also need to show them how they did when they click on submit. So we need another text label that actually shows the result of their, yeah, there we go, under the text box. So it shows them the result, how did they do? Yeah, whether they killed it or they need to try again. So let's just call this the result label, okay? And the text on this, let's just leave it blank because there's nothing there to show yet. As and when they enter their responses into the text box, click submit, then that will show something. So just let's do a sanity check. Looks okay. Yeah, a little bit wonky in the emulator, but it's fine actually. We'll see that as we start coding. Yeah, and now let's write the code. Now, what we are implementing in this app is actually a very powerful concept in computer science called a state machine. And a state machine is simply a representation of the world around us in states. There are objects and these objects have a state and the object transitions from one state to another. Yeah. Like this quiz, at any given point of time, it is showing any one slide. And you could have 3 slides, you could have 36 slides. But the slide you're showing right now is the current state of the application. And when you go to the next slide, you're advancing to the next state. So how do we track these states? We track these with, for example, names and numbers. And here we are just going to track these slides with a number. So slide number 1 through 3. We have only 3 quiz questions. So we're going to track the current state with a number 1, 2, 3, and we'll go from slide 1 to slide 2, slide 2 to slide 3, and then back to slide 1. So every time the player presses the next button, they are advancing the slide deck through the slides. And one way to do this would be to have multiple screens. Did you know you can have multiple screens in App Inventor? So when you look at the menu at the top, where you have screen 1, there's an add screen button, and you can add as many screens as you want. And one way to implement this would be to have one screen for every slide. But there is a problem with that, which is every screen only knows about itself. It doesn't know anything about any of the other screens. It's as if the other screens don't exist, which makes it hard to persist information through the slideshow. So in contemporary computer science, we build apps as what are called single page applications. If you're a web developers love this or hate it, but it's the current style, single page application, where you have just one web page, just one. And instead of having multiple pages, when you want to show new content, on the same page, you move graphical elements around, or you take a graphical element and change its properties. Like you take a text label and you change its text, or you take an image and you change it to a different picture, okay? But it's all on the same page. That's why it's called a single page application, all right? And in this app, we are implementing the same principle in the sense that we have only one screen, and instead of having multiple screens, we change the properties of graphical elements on that one screen only. So it looks like we are advancing one screen after another, but in reality, all we are doing is just changing, the graphics on the screen. So it looks like we have advanced a slide. We have moved from one screen to another, right? So it'll be clear as we go. And so just keep this in mind. This is the web development equivalent, what you do with the HTML, CSS, and JavaScript and web dev. It's called single page application. This is the equivalent of that in a single screen app. All right. So the first order of business here is going to be in some way storing information about every state. Yeah. And to do that, we are going to use lists. We haven't really used lists so much before. So this is going to be exciting. And what is a list? So we all hear about laundry list, right? So it is the same concept. It is a collection of items, but there's a little more to it than just having a collection. There is an order. So the position in the list matters, and it matters for how we manipulate the list to put information in or to get information out. So let's just start using it and things will become clear. Yeah, we're going to have a list for every question, the text of the question. We're going to have a list for every image. We're going to have a list for every expected answer, and so on. And that's how we're going to build information about this state machine that we are building today, this single page application. So let's get started. Each list is going to be a global variable. If you refer to the checklist, then we're going to have a list for, each question, each answer, and each image. Yeah. So let's go to variables. And these are all global variables. So anywhere in the app, any callback, any place in the program recognizes these variables. So that's why these are global. So let's call this one question bank. Right, and there's nothing in it yet. So let's go to lists. And what do we want to do? We want to put all of our questions in a list. So we're going to grab the block that says make a list. All right. I think in a previous app, we may have used lists, and we may have started out with create an empty list and then kept adding to it. But here we already know what we want in that list, and it doesn't change. So we're going to start with make a list. And how many questions do we have? We have 3 for demonstration purposes. You can have any number. It's not restrictive. So when we want to make a list of 3, it starts with just 2 slots here. So I click on this little blue settings wheel and grab this block for item, add it to the list, and I can keep doing that for as many as I want, 3, 4, 5, 6, yeah. But I don't need that many. I just need 3. So I'm going to do 3, okay? And now our questions. So let's start putting the questions in. The questions are all text. And remember, the order is important. So in our slideshow, the first question is going to be about Roosevelt, who met with Stalin and, during after World War. Oh, ancient history. I love history. I never liked it in school, but I like it now. All right. The second question is going to be first. These are all US presidents. So we won't say, every time we won't say first president who, met with Stalin. We'll just say first to visit China. It would be Jimmy Carter. And then impeached. Okay, those are our 3 questions. So now we have a list of questions ready. All right. And now in the similar way, we'll just keep going and we'll create a list of the images that go with each question. So the checklist says call it companion images. We can call it whatever we want, but let's stick with what the checklist says for consistency. And again, this is a list of 3, okay? And just like we did before, the images are pictures and we refer to them with their names in the media drawer, the bottom left here, right? With the exact names. So roosechurch.gif is, if you see any mistakes I'm making, let me know.
Okay.
roosechurch.gif. And then first to visit China, that's Jimmy Carter. And impeached in Watergate. That one is Nixon. Who's there? And now we have our second list ready. And we need one more for the expected responses. So another global variable, and now you know the drill. So I'm going to speed this up a little bit. Go to lists, grab the make a list component, go to text and grab text. Speed this up. We need a list of 3. So go to the settings wheel, add another empty text box. Yes, and what is this name? What is this list for? The expected answers. So expected is gonna have, actually, I made a mistake here. So companion images are, yeah, you can just reuse these blocks. Companion images are,
Yeah, we need the GIF.
right,
Yeah.
exactly. You got it. So which GIF for Jimmy Carter? It's carterchina.gif. And then what GIF for Nixon?
Nixon GIF.
Nixon.gif. Thank you. And then these are the responses that we expect. So the first one was it Franklin? That was Franklin D. Roosevelt, right?
Right.
Yeah. All right. And remember, this is a state machine. So we're going to be going over this list and picking these items for every question that we want to render to the player. And to keep track of which question we are on, we'll need another global variable. And this is the last one that we're going to need. We could just call it index. It's a nice name because like a librarian uses an index to keep track of all the books in the library. We use an index to know which question, which image, which expected answer we are checking out of this library that we have created with these 3 lists. Okay. So that's exactly the principle here. And yes, what do we want it to be at the very beginning? 0 or 1? We'll figure that out. I think these lists are numbered starting with 0. So let's call it 0. And this is why I have the backpack. So I can quickly check and make sure I'm not making mistakes. So sounds like it starts with 1. Okay.
1.
Start with 1. So different programming languages have different conventions. Python has 1, JavaScript has 1. Some start with 1, some start with 0. So yeah. All right. So this is it. Now what we're going to do is, yeah, let's just go quickly to the emulator. Things look okay. Yeah. Let's, there's no question where it says text for label 2. That's right, because we haven't initialized the screen yet. So we are going to now write a procedure to just display any slide, right? So here is where we get a little deeper into the state machine. Let's peel another layer of that onion of state machine. And what we want to do is we want to identify in our quiz on every slide what is changing, right? And what is permanent. So what does a quiz have in the simplest possible way? It has a question. That question has an image. And then it has an expected answer, right? Is the question going to change from slide to slide? Yes, the text of the question is going to change. Good. Is the image going to change from slide to slide? Yes, of course, that's obvious, right? Is the answer going to change from slide to slide? Yes, even though we are not showing the answer, but the result that we evaluate based on what the user entered and comparing that to the expected answer. So that's going to change from slide to slide. So these are what are varying, and these varying components are what we have captured in these lists. And what stays constant? Yeah, the submit button is not going to change. The next button is not going to change. The text box is not going to change, right? So these are going to remain constant. And what we're going to do is kind of like we're going to paint the screen in front of the user each time with only those elements that need to change. Everything else is already there, and it doesn't, the text of the submit button doesn't change, the text of the next button doesn't change, the text box and what it is showing right now, hint for text box, doesn't change. Yeah? So we're going to write a procedure to do that. So let's go to the procedures drawer. Let's just grab the template for the simple procedure that doesn't return anything. We're going to give it an input to tell it which slide we want it to show, right? And let's call this procedure display slide. So I have a convention that I'm following, which procedures are named in camel case, like display slide with D small, S capital, and variables are named with just underscore. Yeah, so, and then we are going to give it an argument. We have to tell it which slide. So let's just call it slide number, slide underscore number. And what do we want this to do? So again, go back to the discussion we just had. What is changing? Yeah, so the graphical elements, the question is changing. So let's go to the text label where we show the question. That's the question label. And clicking on that, let's grab the set method for the text. So set the question label text. Yeah, and that's going to depend on the slide number. And we'll just come to that in a moment. What else do we want to, what else does this procedure need to worry about? The picture is changing, right? So where is the picture? It's this image component here. So click on the image component and get the set method, the setter. So we call these getters and setters. In computer science, very commonly, you can also call them get and set methods. And let's grab the set method or the setter for the picture property. And there it is. And it already has some argument. We don't need that. And what I'm going to set these to is the picture and the question from the list. So we already have the slide number, and now we have the list, and we know that for that list, the number that represents the position is important. So how do we get the item from the list at a particular position? How do we tell the list, give me an item at this index or at this position, starting with position 1, position 2, position 3 for this list of size 3. So let's go back to the list drawer and let's find the method to get the item at a particular position, which is called the index. So select list item. That looks right, isn't it? So let's grab that. We are going to need 2 copies of that. Let's do it one by one and select list item. So it wants 2 pieces of information. Which list are you talking about? And so let's tell it that. So right now we want to give it the text of the question. So let's go to the question bank and grab the get method for the question bank. So this is the whole list. Now it knows that this is the list, and now at which position do we want the item from this list, right? So that's the slide number, which will keep changing, right? And that's why we have the procedure. All right, so now this display slide procedure knows what to show in the text label, right? It's going to the question bank list and getting the item at the particular, at the specified position specified by argument. We want to do the same for the picture. This time I'm just going to duplicate what I just coded here. And I still want to use the same list, and I still want to use the same index. What changes? Yes, I want to use the list companion images, right? Images. I'm done with the question bank. So if I just click on that little down arrow, you can actually select it right from the drop down menu and companion images. That's the list. Okay. Yeah, and the last element is the last list is expected answers, but we don't show that on the screen. So let's not worry about that right now. Okay. And we've written the procedure, but we are not using it yet. We have yet to use it. So the first time we want to use this procedure is when we initialize the screen. So let's go to the screen component. You'll see many events. Let's grab the event handler for screen initialize. So when the first time you load the app, you just open the app. what happens is the screen initialize this event handler, all the code in it that will get run, and also any global variables will be initialized. So all the setup will be ready. Okay. And now this is a very simple thing to do to actually just paint the screen in front of the user. We have just wrote a procedure to do that. We are going to use that procedure and tell it to show us slide number 1. From the mat drawer, big number. Yeah. Okay. So what should happen now, if I've done this correctly, is when I refresh the companion screen. Yes, now it is running the initialize. It is initializing the screen with this display slide procedure. It is showing the right picture. It is showing the right text, and it is waiting for the user, for the player to start playing. Any questions so far?
No,
All right.
no. Mhm.
I'll speed it up a little bit. Sounds like you're following
So
along.
the display, yeah, I do have a question. The display slide.
Yeah.
So it'll take the GIF images and make them into a slide?
Yeah.
Or
So, yeah.
the
Let me go.
initialized global will do that, or the,
Yeah. So good question. So let me just explain what is happening here. Right?
okay.
Maybe it's easier to start with the text label. So the label has a property text, which it is set to just this string that we entered, right? This phrase that we entered here. And there are 3 pieces of information in this list question bank, right? We want only one of them at any point of time. So we will access that one item from the list using the index, which is the slide number, right? So for slide number 1, it will return the first phrase. For slide number 2, the second phrase, the second piece of text. For slide number 3, the third phrase. So it will just return. So if I tell this list, give me what you have at index 3, it will give me this, right? And then this text, which is in here, will be displayed using the text property of the label. Now, just like the label has a text property, image has a picture property, right? So anywhere in this program, we actually are not using a picture. We are just using the name of a picture, right? But this block knows what to do once you tell it the name of a picture. And that's why we have to look very closely at this and give it the exact name, because if we give it a wrong name, then it won't find it in this media drawer. And then it won't know what to do with that. So it will throw an error. But in anywhere in this program, when we say picture, we have in mind an object, right? We are not using that object. We are just using a name that refers to that object. But then this image component knows what to do when you tell it the correct name, right? It will become that picture on the screen, right? So this, after the display slide procedure, it is doing 2 and only 2 things. After it has displayed the text of the question in the label, it will display the picture, based on the name that we gave it in the image component, right? And so the image component listens to the display slide procedure, telling it, hey, look for a picture with this name, Nixon.gif, in the media drawer and become that, right? And then that picture appears on the screen, all right? It paints that on itself, and that's how the picture appears on the screen.
Oh, okay.
Yeah.
Yeah, and that makes sense. Okay.
All right. Yeah. And so to select from the list, we are using the slide number as the index. So index or position. Index is a computer science way of saying which position in that list. And so starting with 1 at the top and 3 at the bottom. So it will just go 1, 2, 3. So you asked for slide number 1. So that's this one, and this one, right? So that's what it will then use.
Okay.
If I use slide number, if I, instead of 1, if I say 2 here, then it's going to just pick this and this, and behave accordingly, and so on. All right.
Okay, thank you.
Yeah, no problem. Yeah, so let's remember to make this one again. Let's make sure this is how we left it. Make it connected and refresh. There. Okay. Yeah, so things are looking better. And we next thing is we want a way for the player to actually now they can already enter their response. We want to tell them whether their answer was correct or wrong. It's just a binary assessment. And so next we will write the code to do that. This time we won't write a procedure. So the assessment is triggered after the user has entered the text in the text box that I'm going to and click the submit button. So what do we want? We want the click event of the submit button. So let's go to the submit button component, grab the event that we have used so many times, the simple click event, the simple and beautiful and versatile click event of a button. And when the button is clicked, what should happen? We want to compare what the user entered in the text box with the expected answer from the list. Are they equal? If yes, tell the user thumbs up. If not, tell the user thumbs down, try again. So you can probably guess that there is a conditional involved because we want to test a true or false condition. Either the answer is right or it's wrong. There's nothing in between. So let's grab an if then else. And what is the condition that we want to test? It has two piece parts, doesn't it? It has what the user entered. Let's get that first. We're going to get that from the text box. So whatever they enter in the text box is the text property of the text box. Let's find the text property using the get method or the getter. Somewhere in here should be a text box text. There we go. We got it. I'm just having some trouble picking and placing it. There we go. There. So this is what the user entered in the text box. It is a text property of the text box component. And what do we want to compare this with? So we want to compare it to the correct answer, the expected answer, which is the one of the elements from this list, right? At the index. So we are tracking which slide we are on with the index. So we know which slide, we know which position we want to extract an item from these lists. And I will go to the list drawer, grab the block to get an item from the list, the same that I've used earlier in the display slide procedure, select list item. Yeah, that's the one. And this time, what we wanted to do is for whichever slide we are currently on, which is this global index here, that's tracking that. We're going to get the get method. So this is the current slide number. And then the answer is in which list? It's in this expected answers, right? So we're going to get the get method to get that list. Yeah, so what this will do now is it will select the item from the list. Which list? The list expected answers, which has the answers to all the three questions. So which of those three do we want? We tell it that using the global index. Yeah, so right now the global index is 1 because we are on the first slide. And we want to compare these two, right? So how do we compare? So these are text, this is text that we are comparing. So let's go to the text drawer and let's find the method to compare text. And this will just tell us if these two texts are equal. Now, sometimes the user may have some space, the player may have some white space, just some blank space before or after their answer, like Jimmy space, 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 Carter, or Jimmy Carter space, space, space. So that piece of information is not useful and it may come in the way of making this comparison accurately. So I'm going to go back to the text drawer and grab this method called trim, which will remove any leading or trailing white spaces. So before or after their entry, if there are any white spaces, it will just remove that. And it will just return the cleaned up text. And that's what we're going to compare with our expected answer. And this compare text returns a true or a false. So if this is equal, if the given answer is the expected answer, then it will return true. Otherwise, it will return a false. And now we can get on with this. And if this is true, if the player answered the question correctly, then these two pieces of information what's in the text box and what's in the list, they are equal. Then what do we want to do? Then we want to tell them good job, right? And we want to tell them this using the result label. So now we're going to go and grab the set method of the result label to set the text to good job or whatever you want to put in there, right? It's simple. And what if they didn't get it right? What if there's a mismatch between what they entered and what's in the list expected answers? And then we want to tell them try again. And that's all that's happening here. It's just a message from the app to the player saying you did okay or you didn't, right? So yeah, that's it. And now our submit button is done. So let's test it out. I love this way of going step by step and testing our app at each step. And we know what is the correct answer here. So we can type in somewhere and submit. Yeah, good job. And let's also
Ah,
type in the wrong answer, right? Let's maybe just type in Roos, submit that and try again. Yeah, so this is working. Also,
right.
all right. So this time after Roosevelt, I just put in some space, white space, and see, it still identifies that it is a correct answer. So when you want to manipulate text, there are a whole bunch of methods in the text drawer. You may want to look at that sometime. We are just scratching the surface here. But yeah, even if they have some blank spaces there,
Mhm.
this will recognize that's just what it is, white space, and remove that using the trim method. Yeah. Okay, so now we've made good progress. They can answer the question. How do they go to the next question? So right now, if I click on the next question, we haven't yet implemented that. So let's get on with that. And also, once they click submit and we know what the answer, what the result is, we know what the result is. We want to clear up the text box, right? We don't want to leave what they entered hanging in there. So that is a simple matter to address here in this when they click the submit button. Let's add one more little piece of code to go to the text box. And now that we have evaluated their response, we can just set the text of the text box to nothing. Right? And this happens now, even if they got the answer wrong. All right. And I'm just going to use the setter for the text attribute of the text box and set it to an empty string. Okay, so that means when I click the submit button, it clears up the text box and then waits for the user to either enter some new piece of information or go to the next slide. Now, the last part of this is going to be implementing the next button. Right? And again, by now, buttons are our friends. So the next button, the click event handler for the click event when the button is clicked. And now that we already implemented a procedure that we can give it any slide number and tell it to show that slide, we can just use that procedure, can't we? So let's go to the procedures drawer and grab that procedure. And when the next button is clicked, what we're going to do is now we're going to increment the index by 1. So if 1 is going to become 2, 2 is going to become 3. And then we're going to call the display slide procedure with that new index. Yeah. There is one issue with this. Can you guess what it is? Just what happens when we get to the last slide? Yeah. So if my logic is just keep incrementing, then 1 becomes 2, 2 becomes 3, and 3 becomes what? So when I reach that last element in that list, I want to go back to the beginning, isn't it? Because there's no 4, there's no fourth item in this list. Yeah. So I want to know when I'm at the last position in any of these lists, when I've reached the end of that slide deck, and I want to go back to the first slide. So guess what I need to do that? I need a if-then statement, right? Where I'll be checking, am I at the last slide? And if I'm in the last slide, then instead of adding 1 to the index, just reset it. to the number 1, right? So in this case, it will check if we are at slide number 3. And if we are at slide number 1, instead of incrementing this index to 4, it will go back to 1. So let's do that. And let's grab the if then else statement. And what we're going to do here first is just check that we haven't reached the end of the list, right? And interestingly, if we go to lists, we can actually query the length of the list. Okay, because what happens if right now I have 3 questions in the list, but what if I add another? Then the size of each of these lists is going to be 4. And then I'm going to have to remember to go back to this event handler and change the number 3 to number 4 if I was looking if the current index is 3. So instead of that, let's just be a little more flexible and just check what is the length of the list. And the length of the list will tell us whether we are on the last slide or not. So that number is going to tell us what is the number of the last slide. So let's get the length of the list, and we can use any list with this, right? They're all the same length. So what we want to check is our current index, what are the 2 things that we are comparing? We want to know where we are, which is this global index. Let's use the get method for the global index. So this is one piece of information. And what are we comparing it to? So this could be 1, 2, 3, whatever. We are comparing it to the length of any of these lists. Let's just pick one. Let's pick question 9. Just duplicated the code from the display procedure. Yeah. So right now the length of the list, what is it? It's 3. And so if I've already reached slide number 3, which is what the global index will tell me, then I want to go to which slide? I want to go to slide number 1. Okay? So let's compare these with the math drawer. Since we are comparing numbers, let's check if the index, which is our current position, is equal to index of the last slide. And if this returns true, now we are ready to proceed. Then we want to, if this is true, then we have reached the end of the deck, and we want to set the index to 1. Jump from the last slide to the first slide, which is 1. And in every other case, we want to increase the index by 1. We want to increment it by 1. So I need both the get and the set, right? The get will tell me what is the index now, and the set will assign it a new value. And since the new value is 1 plus the old value, that's how we reposition the index. All right. So now that we have a new global index, we have updated the index. We can now just call the display slide procedure with the slide number. The list, the index. All right, so we updated the global index. If it was 1, it has become 2. And now we are calling display slide with whatever that current position is, the new current position. And let's check if that's working. So what should happen now is I click on the next button. It should take me to the next slide. There we go. Now I'm on slide number 3. And yeah, clicking on next takes me to the first slide. So this is working. Yep, so now it's all implemented. The whole quiz is pretty much done. And there's just one other little issue here, which is, the text box expects text input, right? So Nixon, for example, submit. Yeah, so this is working. Nixon is right. Let me put in a wrong answer. So this is wrong. So when I submit, it should say try again. Yes. And this keyboard pops up. So when I typed in the text, I used the keyboard on my machine, my computer. I don't want this keyboard to pop up every time. And there is a way to do that, which sometimes is a little idiosyncratic. For the sake of completion, let me show you what that is anyway. I'm just going to go to, it requires using a clock. Yeah. So there is a way to turn that keyboard off if that is an annoyance. Let me go back to the emulator. Yeah, so this virtual keyboard is what I'm talking about. You can just enter your answer from this virtual keyboard. I'm showing right now. MIXON submit, right? But if you find this keyboard an annoyance, then there is a way to turn that off. And just for the sake of completion, I will show you how to do that. And for some very counterintuitive reason, it requires using a clock and a timer. So let's just grab a clock from the sensors drawer and drag and drop it, leave its name as it is, and we'll just change its timer interval to 100. You know. And the way we implement this is I'm just going to go to the clock timer. And just grab this from the backpack. I just grabbed it from the backpack. I don't want to
Okay.
spend time coding this. And what we do is in the clock, when we enable the clock, we want to tell it that you go to screen, you find a hide keyboard method there. Yeah.
Okay.
Yeah. And you can tell it hide keyboard. And when we initialize the screen itself, we want to enable the clock. Yeah. So when the clock is enabled, the timer fires, it will hide the keyboard, and then the clock will turn off its own timer. So that is one place where we want to hide the keyboard. So we go to clock. Since we want to enable the timer on the clock in the initialize method, we grab the timer enabled property and we set it to true. Now the clock will kick off when the screen is initialized. It will hide the keyboard and it will turn the timer off. And then the keyboard will, this will work in, this solves part of the problem. And the keyboard will come back when we hover over the text. When we hover over the text box, see? So I just clicked inside the text box and the keyboard came back. So for that, what we need to do is, when do we go to the keyboard? We can do that at any time. So we can go to the text box at any time. So we go to the text box and there is a got focus event handler. So that tells us when the player clicked on the, moved their mouse or clicked on the text box. So that's when the text box is in focus. So we need to do the same action that we did when initializing the screen one more time when the text box comes in focus. And this seems to work. And in the emulator, it's very quirky. Yeah, so you can see the keyboard still shows up in the emulator. However, when I run the app on my phone, and now see the keyboard came up and it went in a fraction of a second, right? So now I can type in here, whatever, this is Roosevelt. Submit. All right, so far so good. No keyboard. I go to next. Yeah, and no keyboard. And I type in Carter. Submit. Yeah, and so it seems to be working. Yeah. Yeah, so this is good if you don't want that virtual keyboard, but if you want a virtual keyboard, like my Android phone doesn't have any other keyboard. Most phones, most smartphones today have only a virtual keyboard. So you probably want to leave it on anyway. So, so let's, but you know, I just, for the sake of completion, now we are almost done for today. There's one more very important piece of information I want to demonstrate today. So we're going to go a little over time, 10-15 minutes, and we are going to use a dictionary. Okay. So although our current implementation is working and we have used lists, I have so many of these lists. I have 3 of them and it really clutters my code. And there is one other extremely valuable concept in computer science called a dictionary. And very often when we find we have a bunch of lists in our code, and then when we want to modify our code and maybe have 5 questions, 6 questions, we need to keep track mentally of what all these lists are and make sure that they are all of the same length and they are all appropriately set up. It's a lot of rigidity that comes with using lists in our program. And so the other extremely valuable data structure is a dictionary. And if you know about lists and dictionaries, you kind of know 80% of what data structures are in computer science. You use JavaScript, you'll find lists and dictionaries. They might be called hash maps or hashes, but they are essentially dictionaries. And they might be called arrays, and they are essentially lists. Yeah. So extremely valuable to know and handy. And so that's the last thing we're going to do here over the next 10, 15 minutes. So go to the dictionaries drawer, and we're going to replace all these lists with a dictionary. And I'm not going to delete anything. I'll just keep the old code along with the new code. So when you go back and review the code, you can see how it makes sense to use dictionaries instead of lists here, and also what these are and how to use them. Like with databases in our previous app, Pong, we think about lists, dictionaries, data structures in 4 ways, in terms of 4 operations. How do we create new data? How do we retrieve data? How do we update data? And how do we delete data? So create, retrieve, update, delete, CRUD, CRUD. If you just keep CRUD in mind, it will make it easy for you to work with any data structure in any programming language, because all you need to know is, okay, maybe this new programming language has a fancy data structure. Maybe it looks like a list. Maybe they call it an array. But how do I create? How do I retrieve? How do I update? How do I delete? When you know just these 4, it's simple and it's translatable across all programming languages in the software world, right? So we're going to see create, retrieve, update, delete for a dictionary, and then we're going to close for the day, right? And all these lists are going to be replaced by a dictionary. So all the information that we need for this app is now going to go into a dictionary. So let's call this as a global variable with a name. Let's call it bank or library. I don't know. Best name, a library maybe. Because all the information is here, right? And you see the way a dictionary list, you have 1, 2, 3, 4, item number 1, item number 2, item number 3, item number 4. In a dictionary, instead of the position, you use a name, and that's all, right? And the name is called a key. And under that key is called a value. So these are called key value pairs. Right? And you encounter them in web development. It's different, or these key value pairs. Okay. And what do we want now in the piece of text? It's just a label. So I'm going to have a key for all my questions. I'm going to call it Q. I'm going to have a key for all my answers, and I'm going to call it A, just the letters capital Q and capital A. Actually, you know what? Yeah, I'm going to move this aside. And what I'm going to do is, yeah, inside Q, I will have, just give me one moment, okay, to just catch myself here. And what I want in the dictionary is, yeah, is 3. Yeah, just give me one moment. Just make sure I don't, yeah, got it. Okay. Yeah. So this is going to be a dictionary. Where am I? Lost my way there. Hang on a second. Yeah, there we go. Yeah. So in this dictionary, the labels that I'm going to be using are going to be the slide numbers, right? So a label can be a text or it can be a number. And since we are comfortable using a slide number for the keys, I will just use the number 1, 2, 3. Go to the mat drawer and grab numbers. Right now, they're all the same, but we're going to change them in just a minute. So key number 1 is slide number 1. Key number 2 is slide number 2. And key number 3 is slide number 3. And in this key, where you see value, I'm going to store all the information that I need. The question, the image, the expected answer for that slide. And how am I going to do that? I'm going to have a dictionary inside a dictionary, right? And this is a very common practice in programming, to have a dictionary inside a dictionary. The outer dictionary has a name, which is called library. The inner dictionary doesn't have a name. We just retrieve information by using the appropriate key. And we'll see how we do that, right? So the first question, just going to clean this up a bit. The screen is looking a little bit cluttered. Yeah, we'll just clean up blocks. There we go. Much better. Yeah. So what does the first question need? What does the first slide need? It needs a question. It needs an answer, and then it needs an image. We'll call it IM. Again, all of these are just text, right? Get rid of these extraneous bits. Yeah, and what is the first question? The first question is, I can just duplicate it from these lists here, right? So the first question is met with Stalinity. What is the first answer? The first answer is Roosevelt. I'm just going to duplicate it. So I'm not typing a whole lot. And what is the first image? It's this Roos church. Again, all of this is just text. Yeah. And so you see, I've built out my first slide in the dictionary. So the outer dictionary has a key, which is just a slide number 1. And the value, what's the value at that position? What's the value under that label, which is just a number 1? So in a dictionary, there is no concept of position, right? Because that's for lists. We're just using the number as the label. We are just using the number as the key. I could equally call it 11, 12, 13, doesn't matter, right? To be consistent with the global index, I'm just going to use 1 to 3, but these could be any, I could call it slide number 1. Yeah, I could use any slide 1 like that. I could call it, yeah, that is a number, sorry. Let me just show it to you very quickly. Yeah. I could do it like that, right? And then I would put this text in here. Yeah, it's just for convenience that I'm using numbers, okay? So get rid of that, yeah. Yeah, and what's the value? The value is another dictionary. That dictionary doesn't have a name. It's just stored under key 1, and that has the entire contents of that slide. And we're just going to duplicate this, and now you can see how it's the same for slide number 2, except clean this out. It's a different question. It's a different answer. And it's a different expected image. Okay, and I'll duplicate that for slide number 3. Again, clean up. Code is getting a little bit cluttered. And let's get rid of all these and grab question number 3. Stick it there. Answer number 3. The answer to the question number 3. Stick it there under A. And the image for slide number 3. Grab it and stick it under there. Okay. So you see, in one dictionary, now I have all the information. Yeah. And if I decided to add another question, then I would just add another element to this dictionary and just stick in the question, answer, and image for that. Yeah, it is so convenient. So we're not doing that right now. So go back. Okay.
That is really neat.
Yeah. And this is what makes dictionaries so popular. And now that I'm using a dictionary, what I need to do is I need to rewrite my display slide procedure. So I remember I said CRUD, CRUD. So here we have done the first C. How do we create a dictionary? Or how do we create a dictionary of dictionaries, right? Outer dictionary has keys 1, 2, 3. The value is itself a dictionary which has keys Q, A, and IM for question, answer, and image, right? And now how do let's go to the second operation in CRUD, R, retrieve. How do we retrieve information? So with lists, we just stuck the index in there with the name of the list and we got the item at that position. Let's see how to do that for a dictionary. That is the main thing that we'll be doing over the next 5 minutes. So I just duplicated the procedure. You know what? Let me not duplicate it. Let me write from the beginning. Yeah. I'm going to leave this procedure here for reference and create a new procedure. And I'm going to call it new display slide. A new display slide will work in the same way, except that it will work with a dictionary. So it does the exact, it has the same function. It takes a slide number and then it paints that slide. There we go. Clean up blocks just to make things easier to read. Yeah, there we go. Then it's going to have this exact same function. Only difference is instead of getting information from the list, it's getting it from the dictionary. So first, let's get the setters for the label text and the image picture. So let's go to the question label and get the setter for the text property. Stick it in there. And let's go to the image and get the set method for the picture property. So these are what we are going to use to tell it to change that text or that picture. Make this atomic.gif. Okay, and now starts the part about, well, what do you want to show? What do you want to render? So that's in the dictionary. So that's it, using the correct slide number, not as the index, but now as the key. So to query a dictionary with the key, like we query a list with the index, we go to the dictionary drawer and find a method to get the value for a particular key. Here it is, get value for a key in the dictionary. And if not found, what if I put image instead of IM or spelled out answer instead of A, then it will return something. So this can be a helpful error message like found no key. We'll work on that a little more in a minute, but yeah. So what do we want? First of all, we want the dictionary at that particular index, that slide number. We have to tell it which dictionary. We have only one dictionary at this point of time. So that's called library. Let's get the get method for this global dictionary called library. Right. The first thing we're going to do, so is from this dictionary, we're going to get the contents at the key slide number. So hover over slide number, get the get method for slide number. Okay. So now we are using the slide number as a key, right? And when we use this get value for key, it will return the value that it finds at that key. Otherwise, it will return whatever text I have put in here. I could also put in some numbers. I just put in an error message, right? So this is the first level of querying. But look at this, right? What's under that key? That key, which is a slide number, it's another dictionary. And from that dictionary, I don't want to show that whole inner dictionary, right? I just want to show the question. So there's one more step that I need to do, which is from the dictionary that I just got, using this key 1, I need to go one step further and get the text, get the value, which is stored under the key Q. Makes sense, right? To go back to dictionaries, and we need to use this get value for key one more time because I kind of have a dictionary inside a dictionary. right? In fact, in my outer dictionary, I have 3 dictionaries, right? And each of these 3 dictionaries is the whole slide, right? So the result of this first query, let's call it a query, right? The result is a dictionary. So from that dictionary, we want to get the question. So now what we want to do is plug this dictionary as the input to the get value method. Okay. Now use the key to get the question, which is just Q. Okay. There. Yeah. So this first step will return a dictionary, which now becomes the input to the second step, which will now get the text stored under Q. And yeah, dictionaries at first may seem a little intimidating, right? Because we have this nested structure. It's like a tree. There is a dictionary inside a dictionary, and the outer dictionary has a name, and the inside dictionary doesn't have a name but has keys and values, just like the first one. Yeah, but once you play around with them a little bit, it's just such an elegant way of storing information for all those 4 CRUD operations. One gets really addicted to it, right? Trust me on that. And so let's stick that. Now we are now we are getting the text phrase for the question. So let's stick that in to the text attribute of the label component, right?
Okay.
I'm just going to duplicate this whole code block to also get the
Image.
not only image exactly. And what key am I using for the image?
I am.
Yeah, very good, right?
Yeah.
In the hang of it much faster than I did. Okay. And
Oh, this is
so
fun. I like this.
it's fun, isn't it? Yeah.
Yeah.
Yeah. Can do all kinds of useful things with it. And so, yeah, and now, if we go wrong somewhere, we also want to be able to track that. So, although we are not really debugging in any sense here, for the inner dictionary, let's just say found no question. And for
Mhm.
the inner dictionary that returns the image, let's just say found no image.
Mhm.
Should not occur. It will only occur in a error condition, which could be either I gave it the wrong key or I gave it a slide number which is non-existent, right? And in the outer dictionary, let me just put a found no slide.
Okay.
It doesn't change the functionality.
Mhm.
And so now our new display slide procedure is ready. Yeah. Now what I'm going to do is I'm going to disable this block. You can click on this block, the old method that we were using, and click on any block or set of blocks. You can disable it. Yeah.
Oh, okay.
It's a way to play it safe, perhaps, before
Mhm.
deleting it completely.
Yep. Good
So since we
idea.
are transitioning between 2 data structures, let's just leave it for that. And now what did is I went to the procedures drawer, grabbed the new display slide method and stuck it in there. And just like before, this is going to take the slide number as the key, not the index, but the key. And then it's going to show us the first slide. So if you've done things correctly so far, then we should be seeing the first slide. So I'm going to
Mhm.
connect and saying refresh. And yeah, it seems to be working. Okay. Yeah, no problem. So now I
Very
can even
nice.
safely delete display slide. And I'll just leave it in there for the record in case you're reviewing this later on your own.
Yep.
We'll leave it in there. You see, now we are not using the display slide method. However, there is one more place where we need to do this, right? Remember, we were using display slide in multiple places. The second place is when we advance the slide and go to the next slide. So there also, let's disable the display slide method, the old method, and let's just
Mhm.
replace it with the new display slide method. And again, the slide number, we will inform the new display slide method about the slide number in the same way. Both procedures work in the same way, only the implementation is different. And now
Mhm.
let's see that it hasn't broken or disturbed our next method. Again, refresh, right? The first slide loaded correctly. Now if I click on next, yeah. It's doing okay.
Oh, wow.
Awesome.
Oh, wow. That
Yeah.
is nice.
And there's
That's really
one more little change that we need to make. So anywhere we are accessing a list, now we need to actually, we need to actually query the dictionary with the key, right? So wherever we are accessing a list by index, we need to replace it by querying the dictionary with the key, because we'll be deleting all the lists, the final version. Although I won't do that here today. Yeah, so the one last place, I guess, where we are using a list, I see two places, right? I'll only work on this one and leave the last one for the homework. So is when the user clicks when the player clicks the submit button and we compare what we found in what we got from the text box to the expected answer. And now the expected answer is not in a list anymore. It's in the dictionary. So we'll use the same process. And just for the sake of demonstration, I'm going to take this out. We'll leave it there. Won't delete it. And replace it with querying the dictionary. So we get value for dictionary. Yes, and yeah, how did we get the current slide number with the global index? So that's going to be our key. And what's going to be our dictionary? Again, this is a two-step querying process. It starts with the outer dictionary, which is the global variable, this big giant dictionary that has all the slides one by one in it. Yes.
library. Okay.
And now we know that this query returns a dictionary. So we'll go back to dictionary and finish the second step in this process of getting the expected answer this time, which is under the key A, right? Yeah, yeah. If not found, answer not found. And if you've done this correctly, then just contrast these two, right? In the list, we were just passing the current slide number as the index, and we were getting the expected answer from the list expected answers. With the dictionary, we are still using the global index, but we have this two-step process where we get the dictionary for the whole slide at the current slide number as the key. And then from that dictionary, we get only the expected answer, that text, right? Now we can compare.
Oh, okay. Okay. Okay.
Yeah, sometimes helpful to compare how we implement, right? How the contrast between the same implementation, the same goal, but how did we achieve it with the list? How did we achieve it with the dictionary? And now that we have done that, we can refresh the screen and just test that it's working. We go to the text box and I can submit. Oh, it worked. All right.
It worked.
So I can use submit. Yeah. So it's working. And this time, the functionality, nothing has changed. All that has changed is we have used a more advanced data structure called a dictionary. All right. And there's one last place where we are still using a list. Yeah. So I'll leave that as a homework for how to actually replace this. So now we are ready to delete all the lists. So we will no longer have a list. So, but here it still refers to a list. When it checks that we have arrived at the last slide, this is the length of the list. We'll do that, right? So I'll leave that as homework. So one approach could be, just have a global variable, which is the size of the slide deck, the number of slides in it. You could also just look at the dictionary and look at how many keys it has. And you could go to dictionaries and figure out how do we, for a list, it was easy to get just the length of the list. Yeah. So in a dictionary, what we can do is we can get all the keys in this dictionary library and it returns all the keys in a list. So then we can query the length of that list and, we can do that. Okay. So that would be the homework. So
Okay.
it's fun. Try that. I won't give away the answer. All right?
Okay.
So
Okay.
yeah, or I'll be killing on the fun and joy of this, right? So that is this. Okay. And so this is what I plan to cover today. Wow, it's been 1.5 hours, and what we did, just a quick recap, and we'll close. We started out by just getting all the design elements that we needed. Yeah, a bunch of text labels, a text box, a couple of buttons, a horizontal arrangement, all that we have used before, a clock for that quirky keyboard, hiding that. And then we went step by step. The first step, keeping in mind that we are implementing a state machine, we created lists with the information to use for every state in our state machine, which has 3 states, each state being just a slide that we want to show.
Mhm.
So we created these lists. That was our first order of business. Then we wrote a display slide procedure, which accepts as an argument and input a slide number, which can be any number, and then shows the slide working with these lists. So here we learned how to work with lists to get information out of lists. In the first step, we worked with lists in the sense of how do we create lists. Then we actually applied this procedure in the screen initialization event handler, passing the display slide procedure, the index of 1. After that, we implemented the code to evaluate the answer supplied by the player. So we used a conditional statement to compare the answer given by the player, the text, with the expected answer from the list. So we got also to use conditionals with lists. And then finally, we wrote the procedure to advance the slides, again using a conditional to check that we aren't already at the last slide, and picking the correct branch of code to execute depending on where we are in our state machine. And although by this time we had our complete app working, all the functionality was implemented, we felt that lists are perhaps not the most appropriate data structure. They make this whole program very rigid. So for greater flexibility and also for our own learning, we learned how to use a dictionary to replace all the lists. And now I can just delete all the lists and the program is working just on the dictionary. In fact, not only did we use a dictionary, but we used a nested dictionary with dictionaries inside a dictionary, which is very typical for how dictionaries are used in computer science and in the software world. And then we wrote a new procedure that instead of working with lists, worked with the dictionary to get information out to show on the screen in front of the user. And then we used this new procedure in all the places that we were using the old procedure. And so we've the value of this app, I think this app, when I would strongly encourage you to implement this on your own, just delete all the code, every single
Mhm.
code block, every single component on the screen except the screen itself. Start from scratch. Keep the code in your backpack to refer to, but just implement in this flow, which is also documented in the checklist, which I'll post in the Google Classroom uh, in a little bit, right? Uh,
Mhm.
just implement this from scratch. Refer to our implementation that we experienced today if you need to, but really do it on your own and then just go to the backpack to compare your own implementation with ours, with the lists and then with the dictionary. And this is such an important app because it's bringing together all the concepts that are foundational to computer science. What is a data structure? Lists, dictionaries. 80% of the times, these are the data structures we'll be using. What is a flow control? How do we use if then else statements to iterate over lists or dictionaries to get information out or change the information also? We've done that. How do we write procedures and functions so we are not repeating the same code in multiple places? And when we want to update our code, we then don't need to change it in all these places. We just need to write a new procedure or change an existing procedure, and automatically the changes percolate through all of our program. So data structures, flow control, procedures or functions, and then the event-driven pattern, we already are familiar with that. We added one other pattern to our repertoire, which is the state machine, right? How do we use all these three: data structures, if then else, and data structures, flow control, and procedures? How do we use these three to enable a state machine? And what you built really is 80% of the knowledge, that underlies any single page application that you find in web development with HTML, CSS, and JavaScript, right? When we are building web pages, instead of these components, you will have what is called a DOM, a document object model. So all the components that we put in front of the user, which have different properties, will appear in this tree-like structure that we see here, right? We'll use data structures to keep track of our current state, and based on that, change the properties of different components using get set methods as objects, just like what we have done here today, right?
Mhm.
So there's so much of learning in this jammed, packed into this app that I say very confidently, once you have implemented this, your foundation is there, and now you can start experimenting with more sophisticated concepts, including maps, geospatial data, artificial intelligence, Internet of Things, all these other drawers and all the interesting components that are in these drawers. Like, there's a maps drawer, which has wonderful maps. And in one of the apps that I've implemented, instead of pressing the next button, I just use my location on a map to go from one slide to another. So I was visiting San Francisco and I wanted to walk all around San Francisco. And I wanted to walk. I didn't want to take a cab or use a bus. And so I wrote this app for myself. So it would track my location using the components from the maps drawer. And then it would tell me what was the landmark nearby, like the Golden Gate Bridge or the clock tower or Alcatraz prison. It would tell me what is the nearest, it would show me a slide with the nearest attraction, some information about that attraction, and directions to it. And you can do all of that with just the foundation that we have laid here, and just building a house on that foundation. So every app, you can go from here, where to go from here. Every app is now, you have the foundation, explore, and just build a house on that. Okay.
That sounds nice.
Yeah. Okay. So yeah, so much fun, right? All right. So let's stop here for today. And unless you have any questions, we can adjourn for the day.
No, we're fine. I'm fine. I'm gonna review the recording and do it on my own.
Awesome. And next week, we're getting close to the end of this series. And next Tuesday, we'll just be doing a deep dive into some of the concepts here. We'll be doing some practice problems like we always do, alternating between building apps and deep dives. And so you'll get a chance to refresh some of these concepts there itself. There also. All right. Yeah, but do go ahead and try building this out. Let's stop here for the day then. Wonderful hanging out with you. And we'll see you next week.
Thank you very much.
Yeah. Take care.
Okay, you have a good evening.
You too. Bye.
Bye-bye.